Alright, I wanted to do a few more of 3-4 notes part 2. Any numbers to the power of 0 is 1. That's one of those facts I need you to remember for this particular lesson here. That any number to the power of 0 is 1. That means 5 to the power of 0. When you put that in a calculator, you'll see that simplifies to 1. Negative 3 to the power of 0 simplifies down to negative 1. So even if there's a negative in front, that negative gets carried over. 10 to the power of 0, that's 1. 17 to the power of 0 is 1. And even if you get a huge number like 354,117 to the power of 0, that's also equal to 1. So anything to the power of 0 is 1. If it's a negative number to the power of 0, that's equal to negative 1. So keeping that in mind, let's look at this problem a little bit more. So what it says, a certain type of tulips plant is growing in a pond in such a way that the number of plants is growing exponentially. The number of plants n in the pond at time g is modeled by the function ng is equal to a times b to the power of g. So we could see that g is in the power. I'll slide that over a little bit. So you can see that g is in the power. Make that a little bit better. All right. Cool. Where a and b are constraints and g is measured in months. The table shows two values of the function. So you have a table here. I'll give it 3 values of the function. But the first 2 is all you really need. When g is 0, so when that power is 0, your outcome is 125. So we have to remember anything to the power of 0 is 1. So you know 125 times anything to the power of 0, you know that b to the power of 0 is just going to simplify to 1. So 125 times b to the power of 0, you know is going to get you just 125. Which will make that first line true. It'll make 0, 125 true. So that 125 would be a good thing to put in for a. Now, we also have to consider the second part, when g is 2. So when g is 2, it's going to be 10,125. So I'm going to leave that 125 in for that a part, and I'm going to put in 101.25. And then instead of the power being 0, I'm going to put the power of 2 in. Now our goal now is to solve for b, to figure out what that b value is. Because that's what we're looking for here in our multiple choice. So what we do, we have to divide by 125 to both sides first. So we do 101.25, so 10,125 divided by 125. And when we put that into the calculator, we're gonna get a nice pretty number, hopefully. So we get 81. So then we have, or so we have, 81 on the left side is equal to b squared. The opposite of b squared is square root, hence why we practiced all that square root stuff before. Square root of 81 is equal to 9, plus or minus 9. And we get 9 equals b, or b equals 9. So if we change that b and we make that into a 9, and our powers, so it doesn't matter really what power it is, let's call that a g for now, will get us what we desire, our n of g. So our n of g is equal to 125 times 9 to the power of g. So we look in our answers. Obviously we don't have the n of g's in here, but we have 125 as our a, so we know that's not correct. Oop, computer's going a little slow. Good, my c is not correct. My e is not correct because of 125. Now we know our b is 9. So with the only one being a 9 for b, we know our answer is D, as far as our multiple choice. And our formula to find out all the tulips that we need to write is right there. N of g is equal to 125 times 9 to the power of g. Alright, let's do another one. Let's talk about daisies. Try to make it a little bit smaller so you can see. How about we can go a little bit bigger there? Cool. Alright, so a certain type of daisies plant is growing in the pond in such a way that the number of plants is growing exponentially. The number of plants n in the pond at times c is modeled by the function n of c equals a times b to the power of c. So we have an exponent involved here, where a and b are constants. That's in our key component. And c is measured in months. The table shows the values of the function. So the output of the function after 0 months, there's 132 daisies. So when we put 0 in for c, we get an answer of 132. So I'll try explaining it a little bit differently. So my output, I get 132 daisies is equal to a times b to the power of 0. B to the power of 0, you know, is really just 1. So a times 1 is really just a, but I'll write it out anyway. So 132 is equal to a times 1, divided by 1 to both sides. So, come on, 132 is equal to a. And that's how we know our a value. So we put that a value in. So n of c is equal to the a value of 132. Now we don't know what our b is, so we put a b in. And then we know 0 was our c, so b to the power of 0. So our initial amount times 132 will get us the answer of 132 daisies. Next step, we want to then put in the value of c. After 5 months, we get that many daisies. So better yet, I'll do that in red. So after 5 months, we get that many daisies. So we put 5 months in, and we get a total of that big amount, which is 4,325,376 daisies is equal to 132 times b to the 5th. Now our goal here is to solve for b. So we first got to take that big 4 million number and divide it by 132, and we get 32,736. So I'll write that on the board. 3, 2, 7, 6, 8, and that's equal to b to the 5th. Now we have to do the opposite of b to the 5th. The opposite of b to the 5th is the 5th root. So I do the 5th root to both sides. And how we go about doing that in the calculator, we do 5 for 5th root, math, scroll down to number 5, so it's an x square root. Then we type in the number, parentheses, 32768, close parentheses, and a 5th root of this big number, b, is going to equal 8. So So that means we got to put 8 in for B. So our final answer is going to be N of C. Oh, that's going to go off the screen. N of C is going to equal 132 times 8 to the power of C. So 132, I'm going to cross out B, C, and D because all those A values. But we have A, E, and F is 132. Then we have an 8 in for the B spot. So our answer is A for this particular problem. Since we got time, let's do one more. Let's talk about daffodils. A certain type of daffodil plant is growing with adjustments, okay. Is growing in a pond in such a way that the number of plants is growing exponentially. The number of plants n in a pond at time j is modeled by the function a nj times a times b to the power of j. So that's our formula. We're going to first plug in this first coordinate here. 0 goes into the exponent and the answer of 148. So 148 is equal to a times b to the power of 0. Now b to the power of 0 is 1, so that means a is equal to 148. So I'm going to put in 148. It's that a value of a times b to the power of j. Now, let's do the second part. I'll underline in blue. We put the 4 into the power, we should get an output of that, of 92,500. So 92,500 is equal to 148 times b to the power of 4. Now our goal here is to solve for b. So it means we have to divide both sides by 148, so 92,500 divided by 148 gets you 625. So 625 is equal to b to the 4th power. The opposite of b to the 4th power is the 4th root. So we got to do the 4th root to both sides. So 4 math x square root parentheses 625 close parentheses, you're going to get 5. So b equals 5 because we took the 4th root of 625. So we're going to get 148 with b with a 5 there, so our answer is A for this one also. Alright, I know this will be a little bit challenging, so there's material here. But here's your classwork to practice with and your homework. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out after school. Alright, have yourself a good night.